Guglielmo, I do not see you, but I'm going to introduce your seminar. So today we have a research seminar together, and we have the pleasure to look at an area in which we are not, with which we are not familiar at the chair. So it is even with more interest that we will attend your seminar, Guglielmo, on subjective perception to climate change and the research you have done on Bangladesh data.
Okay, thank you very much for having me here, and it's a really great pleasure. And despite the circumstances, I hope that we will be able to meet in person soon. So I said today I will be presenting my ongoing work that studies the relationship between subjective perceptions and adaptation strategies to climate change, providing evidence from Bangladesh. So throughout the presentation, please feel free to interrupt and jump in for any question. Just unmute yourself. So starting with some motivation around this topic, well, let's start from the scientific consensus that nowadays there is around the impact of climate change on agricultural activities, with the projected changes from the Intergovernmental Panel of Climate Change, that the increase by 2 degrees Celsius would reduce the agricultural output by 25%. And indeed, this effect will be even more important and even more dramatic in those tropical Asian countries, among which there is Bangladesh. Bangladesh has been ranked 7th on the Global Climate Risk Index in 2019 of the countries most affected by climate change since 1998, and additional predicted changes due to climate change have quantified that the increases in droughts by 2050 would cause a 40% reduction in crop productivity, and a similar figure would be caused by the changes in the erratic and the variability of rainfall. So what is even more important in this case is try to understand what those communities that are more vulnerable to climate change, and therefore rural households, what they can do to avert the challenges and the threats posed by climate change. One of the facets of the area of adaptation strategy studies the potential changes to farming and land management decisions that we broadly define as on-farm adaptation strategies. Generally, there's a growing strand of the literature that has been studying adaptation strategies to climate change, and there is quite some consensus around the identification of resource constraints as the most significant and considerable determinant of adaptation. However, there is a bit of a debate around the role that other potential factors may play in the determinants of adaptation, and in particular the so-called psychological and cognitive factors around which the presentation of today will hover. So adaptation as investigated by Burke and Emmerich in 2016 in the US, may also be limited by a difficulty in learning about climate change and by cognitive heuristics and biases that individuals may be put in place or suffer from. So with all of this in mind, it is really key and essential to try to understand if and how, if in any way, subjective perceptions of climate change can shape the adaptation decisions. So what my paper does in particular, it addresses the research question of the role of subjective perceptions of increases in droughts on the irrigation decisions of rural households in Bangladesh. So in order to do so, I empirically test the hypothesis using a panel dataset of rural households in Bangladesh using a two-way survey between 2010 and 2012. And I adopt an individual and time-fixed effects methodology on the panel data that first try to quantify and understand the role of subjective perceptions on irrigation decisions, disentangling the direct and indirect effects of the psychological component on the behavioral response of the agents, and then I explore 3 different mechanisms through which cognitive factors may play a role. So firstly, on the effect of the timing and the severity of drought events on irrigation, and test it whether the inaccuracy of on the time of the events may play a role. Whether the inaccuracy may play a role. And finally, I explore whether the overestimation in the frequency of past drought events may also play a role in the irrigation decision. So overall, the main contribution of this paper is to shed light and provide some original evidence on the role of subjective perceptions and cognitive factors on the on-farm adaptation decisions to climate change. So this paper broadly speaks to 3 different strands of the literature. First and foremost, the literature that is studying on-farm adaptation strategies to climate change in developing countries. This is done by using different temporal and geographical coverage that ranges from Chile, as in the case of Aragon and co-authors, who study input use and domestic labor as adaptation margins, or by Alfamer and Carlstone, who study crop choices in India, or again, Kurukula-Soria and co-authors and Taraz, who focus on irrigation, as I do, but respectively in Africa and in India. It is to be said that none of these papers embeds the role of subjective perceptions. Indeed, most of the time it is because of a lack of available data, and this is where I try to add on in terms of empirical evidence, taking advantage of the survey data that I use. There is, however, a second strand of the literature that in fact tries to explore subjective perceptions of climate change and adaptation strategies. This is done through very small-scale surveys in restricted geographical areas, either in Africa or in South Asia, and more in particular in Pakistan and Nepal. However, the main approach of these studies is doesn't really put in relationship a study the relationship between perceptions and adaptation strategies, but only study the determinant of perceptions through that are collected through cross-sectional surveys, and therefore cannot really put in place the individual fixed effect methodology that allows me to identify the role on the subjective component side. Finally, the paper also relates to the growing literature on the expectation formation process about climate change. The Rubina tests a number of different cognitive heuristics on belief formation about climate change as representativeness and availability. And the formation of and the subjective probabilities of climatic change is tested as having an effect on various outcomes by Alem and Colmer of Genet, among the others, who study the effect on consumption smoothing and subjective well-being. So let me briefly give you a preview of the main findings of my research. Well, first, subjective perceptions of increases in droughts are found to have a direct and an indirect effect on irrigation decisions, whose the latter depends on the long-term drought exposure. And these summed all together make up the so-called belief effect, the subjective component that leads to adaptive decisions. And then I test a number of different mechanisms through which cognitive factors affect decision-making in terms of adaptation. The first one regards the severity and the timing of the drought events, and I find that Salience explains how households make irrigation adaptive decision, finding that first, only self-reported 1-year lagged drought events have a statistically significant effect, and farther away in time shocks have a null effect on the irrigation decisions. And then I also compare the self-reported year of the most harmful drought with an objective counterfactual and build a measure of inaccuracy that shows that being inaccurate may lead to potentially suboptimal irrigation decisions, meaning increasing the land under being rain-fed after a drought event. Finally, I shift my attention to the frequency of past drought events and compare self-reported and objective number of drought events, finding that overestimating the number of such events leads to a higher share of irrigated land and a lower share being rain-fed. So with all of this in mind, the roadmap of today's presentation will first start with some background and context on the empirical setting that I implement and description of the data. Then I will move on the theoretical framework that embeds the relationship between subjective perceptions and adaptation strategies, the empirical approach that I adopt in order to validate the hypothesis, and finally displaying the results and discussing the mechanisms before concluding. So Bangladesh, for those who are not familiar with this country, is characterized by a tropical monsoon climate with 3 growing seasons. The agricultural production in Bangladesh is mainly represented by rice production, which is the most produced crop. And it is so important that each of these 3 growing seasons that characterize Bangladesh take the name of a typology of rice crop during it. So there's really a one-to-one correspondence between the growing season and the typology of rice cropped. So the house type of rice is cropped in the pre-monsoon season, the so-called Kharif 1, that ranges from April to July. The Aman type of rice in the monsoon season Kharif 2, between July and November. And finally, the Boro type of rice is grown in the winter season Rabi, between December and May. So each of these 3 growing seasons is characterized by very different climatic characteristics that may also explain the irrigation decision afterwards. So let me give you a brief summary of the main characteristics. The house, so you see that I will call throughout the presentation, I will refer to the type of rice as representing the growing seasons. House is characterized by erratic and variable rainfall and high temperatures. Aman, grown in the monsoon season, is indeed characterized by heavy rain and floods, and in this season more than 80% of the annual precipitation occur. And finally, Boro, the winter season, is characterized by low temperatures and dry weather. So in terms of irrigation in Bangladesh, there are 2 main sources of irrigation. On one hand, surface water, and on the other one, groundwater. And it is indeed the latter that plays the most important role, with more than 80% of total irrigated area that uses groundwater techniques. In fact, there are 3 main technologies of irrigation in Bangladesh. The first one is shallow tube wells, which is characterized by a pumping unit that uses a motorized succined mode and extracts water from shallow aquifers, so with a depth that is lower than 45 meters. And it is on the other hand, there are the deep tube wells as an irrigation technology that extracts water from much larger depths that can reach below 150 meters. And finally, there's the low lift pump, which draws water from rivers, creeks, and ponds. So in any way, the first 2 of these 3 irrigation techniques are the most important, and those that will be the object of my study. And you can see that the shallow tube well, the STW, and the deep tube well, the DTW, comprise more than 78% of total irrigated areas in Bangladesh. For those who are interested, I have a, which doesn't work. I can. Okay, there's a figure I can also show you later on the differences that really just depend on the depth of the aquifers that can be reached through the 2 different techniques. So if there are no questions up to now, let me move to the presentation of the data that I use in the empirical setting. The main sources of data are three. So the first one is the Rural Household Survey that is has been conducted by the International Food Policy Research Institute, IFPRI, between 2010 and 2012. This is the so-called Bangladesh Climate Change Adaptation Survey, and the greatest novelty of this data is the presence of information, subjective perceptions about climate change, and self-reported incidents of past weather events, among which drought, which is the focus of the study, and besides all the socio-demographic information and agricultural characteristics of the household. This is matched at the union level, which is the finest administrative level in Bangladesh, whose size is around 10 kilometers, to give you an idea, 10 to 20 kilometers. Is matched with objective drought exposure data. These are taken from the standardized precipitation evapotranspiration index, the SPEI, from Vicente Serrano and co-authors. These data are provided with a 0.1 times 0.1 degree scale and with a monthly resolution. I also use the MDAT database for robustness to compute the number of drought events that has occurred in the same time period in Bangladesh. So with a deeper investigation in the presentation of the Rural Household Survey, it contains information on two different waves that have been conducted respectively in January 2011 and in September 2012. Each of these waves has interviewed 800 agricultural households that have been randomly drawn from 40 randomly selected unions, whose centroids is shown in the right-hand side of this slide. One of the most interesting features of this survey is that it has a very low attrition rate, where more than 97% of the households have been re-interviewed in the second round. However, given that the focus of the study is really on the subjective component, I restrict the sample to those observation whose respondent, meaning the head of the household, has been the same in both ways. This leaves me with a 714 wave with a total number of observations equal to 1,428. I also checked for attrition, and I don't know why the hyperlinks do not work. I believe it's because of I could actually shift to, well, anyway, I can show you later. I'm sorry about this. I believe it's a technical issue with Zoom, because that was working. The differences in means are not statistically significant for any of the main covariates in my empirical specification. So let me provide you some summary statistics to better understand who are we talking about, meaning as the object of this study. So the respondents are the head of the households, and most of the times they are male, with quite just on average 3.5 years of education completed. And you can see that households do not really rely on agricultural workers, and rather rely on self-employment in household farming activities. And we are talking mainly about smallholders. As you can see that the area of cultivable land in hectares is around 0.5 hectares. And there is quite enough heterogeneity across the different types of soil quality that their cultivable land is characterized by, and here I'm reporting the weighted shares of each of these 5 types that will be part of my covariates in the empirical specification. But I mean, the main interesting point indeed is the presence of this subjective perception. So what are we talking about? We have 3 different measures of subjective perceptions around different features of climatic changes, namely an increase in droughts, an increase in erratic rainfall, and a decrease in precipitation. So this is computed through extrapolated from the questions using computing simple dummy variables that report that are equal to 1 if they report to have perceived each of these changes in climatic features, and the quite meaningful change in the average share of people who have perceived each of these features of climate change between the two waves provides and lays the groundwork for the reason why I need to take into account objective drought exposure and general weather characteristic to make a meaningful comparison with the subjective component, especially because by looking at objective data, there is no evidence of any of dramatic drought event between the two waves that might have driven this spike in the second wave respondents stating yes. So in terms of agricultural characteristics of the households, so you can see that this provides quite a representative sample as what I've been discussing about in the context of Bangladesh in general. So you see that most of the times farmers produce and grow aman and boro, which make up more than 70% of the share of total agricultural production in over a year, and so reminding that aman is the typology of rice grown in the monsonic season and boro in the winter season, and these will be in fact the main periods in which I will focus my analysis. With this in mind, let me show you some descriptive statistics on the use of irrigation across the different waves and across growing seasons. You can see that in the Aman, again, the monsoon season characterized by heavy rain and floods, most of the cultivable land is left rain-fed, meaning that there is no irrigation implemented, and this holds for across the two waves, whereas the remaining part is mostly just used in irrigated by STW and DTW. The figure are considerably different if we look at the boro. Boro is the winter season characterized by dry weather, and here you can see that the share of cultivable land and all of these shares are weighted by the extension of the plots. Left rain-fed, you see that is much smaller. It accounts to, let's say, around a fourth, and much more land is left to is irrigated either through STW or DTW. So this rural households data is matched with objective drought exposure data, as I stated before, at the union level. So I use the SPEI, which is a climatic drought index that combines precipitation, evapotranspirations, and temperature variability in order to provide a measurement of droughts. So the SPEI is nothing but an index that ranges from -3 to 3, and it accounts for a standardized probability where 0 indicates the median amount, and the lower, in fact, the value of SPEI, the larger the probability and the more severe the drought has been. So following the literature, I can classify 5 different classes of droughts, depending on the cutoffs of the SPEI. So as I just said, above -0.5, if the SPEI is above -0.5, then it is defined as a non-drought environment, whereas the more the SPEI lowers, the more severe the drought is recorded to be, up until the maximum being the most severe drought being the extreme drought event. So I compute 2 different classes of variables based on the SPEI. First, I build continuous exposure measures, respectively the long-term average drought exposure, which represents the 20-year average of the SPEI index over for each union, and this somehow is the objective counterfactual of the question on the perception of an increase in drought that we have seen in the rural household that has the same time span of 20 years. And I also compute the short-term deviation meaning the difference between what has happened in the year before minus the long-term average exposure. And for ease of interpretation, all the results I will be showing you have these variables taken in their additive inverse form, which means that higher values of these variables are associated with the stronger droughts. I also can compute the number of objective drought events, so building up count variables, and I do so by using this definition. So I can compute the number of moderate, severe, and extreme droughts, and in particular, I can also match that with the number of self-reported drought events that the households reported to have experienced. So by using the same time span, both in the self-reported data from the survey and the objective data using the SPEI, I can create a measure of accuracy that I define as delta, which is the distance between the self-reported number and the objective number. So you can see that a delta above 0 would indicate an overestimation of drought events. A delta equal to 0 would be a farmer who's accurate, and a delta below 0 would mean underestimation. So just to give you an idea of the distribution of these variables depending on the cutoff that I use at the to define the droughts in objective terms, you can see that if I use moderate and severe droughts, whose cutoff is reported in brackets here, you can see that we have quite a systematic pattern of underestimation among farmers. Whereas if I use extreme droughts, which are again the most restrictive cutoff, you can see that most of the farmers are in fact accurate, and the distribution is right skewed with more observations that overestimate and just a few that underestimate. So using this, with this evidence in mind, I will use extreme droughts as the main objective counterfactual throughout the analysis, the empirical analysis, but I will also use moderate and severe cutoffs to check for robustness. So if there are no questions up to now, let me talk about the theoretical framework that designs the relationship between subjective perceptions and adaptation strategies. So I rely on the literature, and in particular by Bento and co-authors Haggerty and Xiang, who have implemented a similar framework in order to study the effect of climate on different outcomes and quantify the effect of adaptation. So there are two main differences with respect to their approach. So first, as I already said before, I can explicitly measure and observe both the adaptation strategy, which will be my outcome of interest, and the subjective perception. So thanks to the richness of the data, I can design a theoretical framework that I can empirically validate afterwards, where the adaptive decision A for household I in year T is a function of the drought exposure E, IT, which can be decomposed into its average, long-term mean, and the tilde, E tilde, which is the short-term deviation, and is also a function, the adaptive decision, of subjective perceptions, omega IT, which is in turn a function of the long-term average drought exposure and a set of covariates. So usually what the literature would do is to compute the different impact of climate, disentangling the role of short-run and long-run effect, that the short-run effect is nothing but the derivative with respect to E tilde of the adaptation decision, and the long-run effect. The long-run effect would be quantified by the direct effect of drought exposure plus the effect of changes in long-term average drought exposure through the subjective perception channel. And this is what I'm interested in, and this is what I eventually can quantify in this study. In fact, what I aim at quantifying is the effect of the subjective component of adaptation that, under the assumption that agents form beliefs over long periods of time, as I said before, referring to the empirical setting, I will use a 20-year period of time as a long-term average. The belief effect will be the sum of the direct belief effect, so the change in the beliefs, in the perception of an increase in droughts that drives the adaptation decision, plus an indirect belief effect that depends on E bar, which is the long-term average drought exposure. So how can we move from here to the empirical setting? I implement, as I said before, a panel data a specification that adopts household and year fixed effects, but most importantly, it includes both the direct and indirect effect of subjective perceptions on the adaptive decision. So the adaptive decision that I focus on is YAT, which is the share of cultivable land under an irrigation status, being respectively rainfed, STW and DTW, in 2 growing seasons, Aman, the monsoon season, and Boro, the winter season. So as I said, so here I'm providing like kind of a universal approach to all the irrigation techniques that have been that are implemented in Bangladesh, as we have seen through the summary statistics before. I also include as a main covariates the lagged seasonal deviation from the long-term average drought exposure, the long-term average drought exposure, but most importantly, I include the subjective perception of an increase in drought, so the dummy variable that I described you before, which is omega IT, whose coefficient of interest is gamma free, and the interaction between this the subjective perception and the long-term average drought exposure, whose associated coefficient is gamma 4 and is the other coefficient of interest. I also include a set of control variables at the household level that I will explain in a second, and I use spatial heteroscedasticity autocorrelated consistent standard errors with 2-year time lag because of the time span between the 2 waves, and 200 kilometers spatial correlation because this is the average distance between the unions in the sample. As I said, the number of control covariates that I include in my specification is at the household specific and time varying level, and it relates mainly to agricultural characteristics and individual characteristics that may confound the effect of subjective perception on adaptive decision. So I include a control as being a farmer or not, receiving extension advices, having electricity connection, the type of the soil of cultivable land that is shown to have a role in irrigation decision. I also control for the total hectares of land holdings in order to potentially account for wealth and economies of scale channels. And finally, I also include the additional 2 subjective perceptions variable of erratic rainfall and a decrease in precipitation in order to potentially account for correlation between these subjective perceptions measures that may confound the identification of the effect of the subjective perception of an increase in droughts that I am interested in. So if we want to bridge what I have described through the theoretical framework with the empirical approach, the total marginal effect of beliefs includes both a direct effect, which is gamma free, which is the marginal effect of perceiving drought events, and an indirect effect, which is gamma 4 and depends again on the average long-term drought exposure. The explicit observation of these measures is even more important and motivated by the recent literature that argues that the analysis of weather fluctuations as such on outcomes and on adaptation decisions may not be sufficient, since differences in preferences, beliefs, and the experience with the local climate may affect adaptive behavior. So let me move to the results. The main results are displayed in this table that shows the effect of the the four main coefficients of interest on the different irrigation decisions across the growing seasons. So I would like to draw your attention on the first two columns that report as an outcome variable the share of rain-fed land in Amman and the share of irrigated land by STW in Amman. So you can see that the perception of an increase in drought has a positive, statistically significant effect on the rain-fed land and a negative statistically significant effect on STW. So this would sound somehow counterintuitive in a sense that perceiving an increase in drought would lead the farmer, if we had to interpret this in marginal terms, to an 8.7 percentage point increase in the share of rain-fed land and a 5 percentage point decrease in the STW irrigated land. Nevertheless, by introducing the interaction term between the perception and the long-term average drought exposure, we see that we have a statistically significant attenuating and in fact counterbalancing effect of the subjective component on the irrigation decision, whereas the coefficient associated with the interaction term is negative in the case of using the rain-fed land as outcome, and is positive when using the STW irrigated share of cultivable land as outcome in the Amman season. So if we wanted to quantify the belief effect, under the assumption that there is a mild drought exposure, meaning an SPEI equal to 1, and this is just done for ease of interpretation of the results, the total marginal belief effect, which is nothing but the sum of these two coefficients, whose p-value is reported here to be below the critical conventional thresholds, would lead to a decrease by 46 percentage points in the share of rain-fed land during the Amman monsoon season, and an increase by 39 percentage points in the share of land under STW irrigation. So these are quite huge changes, but again, it's under the assumption that the drought exposure has been mild over the 20 years, which again maybe is again quite considerable over the last 20 years time of reference. So with this in mind, with this baseline specification, I explore three different channels through which cognitive factors may shape the behavioral responses that in fact here are studied as the irrigation decisions. So in order to do so, I use two different dimensions of the drought events that are equivalently important, which are on one hand the timing and the severity of the droughts, and on the other hand the frequency of these drought events. So respectively, I will first look at the salience of the drought events, whether the timing of the most harmful drought explains the irrigation decisions. Finally, I'll test whether this the recollection of the timing of the harmful droughts is accurate or not. And finally, I will move to the analysis and the consideration of the role of accuracy, and in particular overestimation in the case of the number of droughts experienced. So the first mechanism that exploit is salience. So we have seen that long-lasting beliefs on changes in the long-term distribution of droughts matter, but to what extent do they matter? Well, we want therefore to explore whether salient events, meaning some changes that do not necessarily change the long-lasting underlying beliefs, may lead to an overreaction and therefore a behavioral response for the farmers. So the empirical specification that tests this hypothesis enriches the baseline specification with two event time indicators, WIT minus tau, which are respectively an event time indicator that track the year of the most harmful drought, meaning if WIT will be WIT minus 1 will be equal to 1 if the farmer has reported that the most harmful drought has occurred the year before the survey, and similarly if with the WIT minus 2. So let me show you the results in this table that are quite interesting and quite clear. So the main coefficients of interest are again lag -1 and 2-year lag, 1-year lagged and 2-year lagged salient drought events. And in fact, here it is striking that we see that only 1-year lagged events, self-reported drought events matter, and in particular they lead to the implementation of behavioral responses aligned to what we would expect. So a farmer would increase the share of land under STW irrigation and decrease the land left rain-fed. In the Amman, in the borrow season, this may raise some doubts on the relationship between the salience of the events and the behavioral response that has a positive effect on the DTW irrigated land and a negative effect on the shallow tube well. So if you, as you may remember, I have explained that the STW, the shallow tube well, extracts water from shallow aquifers, and the borrow season is characterized by a dry weather. So potentially, given that the weather is already dry enough, further droughts may be not only meteorological droughts, but in fact groundwater droughts that drain up shallow aquifers, and therefore agents may be more prone to increase the land under DTW and decrease the one under shallow tube well irrigated system. What is even more interesting here is that we see that the 2-year lag, the self-reported drought event, does not explain at all any kind of behavioral response. So the short time lag is indeed explained because this is the time span in between the two waves, but I think that this is already quite striking as such. In any case, somebody might say, but here we're just looking at self-reported data, and we all know that these may be subject to recall errors or reference dependence. So what is to do is to try to find an objective counterfactual of the year of the most harmful drought and compare it with the self-reported one. And this is what this new specification does and empirically tests with the introduction of this dichotomous variable dit-1 that takes value equal to 1 if the self-reported year of the most harmful drought, meaning the year before, does not coincide with the year in which the most severe drought has been recorded to have occurred in using the SPEI index. So here I'm really just taking the minimum value of the SPEI index over the same time span over which the survey questions are asked, and I identify that as the objective counterfactual of the most harmful drought for each farmer. And if the year reported by the farmer and the year in which the most harmful drought has occurred differ, then this variable will take value 1. So let me show you the results in this case, where the coefficients of interest is the one associated to the inaccuracy of salient events variable that I have defined before. And here you can see that, in fact, being inaccurate, meaning I do not report last year as the most harmful drought, even though, in fact, objective data report that last year it was the most harmful drought event, will lead me to put in place behavioral responses that potentially are considered suboptimal, in a sense that if I'm inaccurate, I will be more prone I will increase the share of land being rain-fed in the Amman season. And with the discussion around the potential presence of groundwater droughts in the borrow winter season that I gave you before, you see that here as well we have this effect where inaccuracy drives the implementation of potentially suboptimal behavioral responses, with an increase by 11 percentage points on the share of shallow tube well irrigated land, and a decrease by almost 7 percentage points in the deep tube well irrigated land. So we have seen so far the role of the severity and timing of drought events. But what about the frequency? Perhaps farmers will also change their behavioral responses depending on the amount of the number of droughts that they have been exposed to. So this is what I test in the last mechanisms here that where I use the measure of accuracy delta that I presented you before, that is nothing but the distance between the self-reported and the objective number of drought events, of course, in the same time period. And I include to the baseline specification this new measure, overestimation, and where I exploit both the extensive margin through an indicator measure overestimation that takes value 1 if delta is strictly above 0, and also the intensity of the inaccuracy as using the delta as such. The results are very clear and straightforward, in a sense that when I'm just focusing at the extensive margin here, you can see that overestimating the number of droughts leads to an overreaction for the farmer that reduced the land under rain-fed and increased the land under STW irrigation in the demand season. And once again, we have this clear pattern of substitution in allocation of irrigation in the borrow season between in favor of the deep tube well irrigation at the cost of shallow tube well irrigation. Results are robust, only in the case of the in the demand season when I'm exploiting the intensive margin of the inaccuracy. And even more interesting here, also both the shallow tube well and deep tube well have a specification, have a statistically significant and positive effect of being overestimating the number of drought events, whereas when I'm looking at the rain-fed cultivable land, this overestimating the number of drought events will lead to a reduction in the share of land left rain-fed. So this is these are the main results that I have shown you so far, and I also test for the robustness of these results. Now, given that I saw before that the all the hyperlinks do not work, I may this may be more difficult. I will need to stop sharing and start sharing again to let them work. Maybe I could do that if this is fine with you. I'm sorry. Because otherwise this may be more difficult. Let's see if this way they work. Yeah, they do, in fact. Great. Can you still see my screen, right?
Yeah.
Great. So the main, the most important robustness checks that I perform on the baseline results is a sort of falsification placebo test. What I do is that, as you may remember, the belief effect was depending on a direct effect of subjective perception and the interaction term with the long-term average exposure. So what I do is that now I create a new interaction term that interacts the perception with deviation with drought exposure. And in fact, what I find is that the effect, the total belief effect, does not depend on the level of the deviation drought exposure, that in fact is statistically not significant in any of these specifications. I also test for the robustness using a different outcome variables, meaning the hectares of cultivable land. This is, and you see that when I use the correct interaction term, the results are robust. And in fact, we have this again, a counterbalancing effect of the interaction term on the outcome on the irrigation decision, also that appears as statistically significant also in the borrow season with the correct sign, and whose p-value on the joint significant in the sum of the two coefficients is again below the critical thresholds. And I also once again perform the kind of placebo falsification test that uses the interaction term between the perceptions and the long-term and the deviation, sorry, from the long-term average drought exposure. Robustness is also tested on the set of mechanisms that I have investigated. Here I'm going to be faster in the interest of time, but I'm building different measures of salient droughts that only simply look at first the lag, 1 year lagged and 2 year lagged. And again, here we see that 2 year lagged never matter. as events, I also try to build and run a regression that only includes objective counterfactuals of lagged droughts that still seem to drive the in the right direction the behavioral responses of the agents. And finally, I reduce the sample size when testing the accuracy hypothesis of overestimation in the frequency for those subsample of those who overestimate, meaning having a delta above 0. I also use different drought cutoffs. So you might remember that I have always been using extreme drought events as the objective counterfactual. However, to check that the results are not driven by the arbitrary choices in the cutoffs, I also build the accuracy measure, meaning the ones that I also showed you through the plot of the distribution before. And you see that again here, overestimating leads to a behavioral response in favor of increasing the land under irrigation and decreasing the one in rainfed, for example, when I use moderate droughts. Finally, I also use the MDAT objective drought events number as the objective counterfactual, and I find that the results are robust. And I'm happy to go through any of these channels and tests more in detail during the discussion if you're interested in that. Let me conclude by saying that we have started from the idea that beliefs in climate change and limited rationality may be a potential adaptation gap that remains yet unexplored. And this study aims at providing some first empirical evidence on the role of subjective perceptions on adaptation strategies. And in fact, I find that the effect of subjective perceptions of increases in droughts on the irrigation decisions depends on the level of long-term average drought exposure. And I also provide evidence on 3 different channels of the effect of cognitive factors on adaptation. The first 2 exploiting the timing and the severity, and the third one exploiting the frequency, finding that only 1-year lagged drought events have a strong statistically significant effect on the share of irrigated land, and for shocks farther away in time, the effect is null. Finally, inaccuracy of the timing of harmful drought events maybe is linked with potentially suboptimal decisions. And to conclude with, overestimating the number of events seems to be leading to a higher share of land under irrigation and a lower share of land left rainfed. So I thank you all very much for your attention, and I'm happy to discuss and answer any questions you may have.
Thank you very much, Guglielmo. Very interesting.
I was.
Yeah, and I think that this question may be also enlarged, by the way, to many other contexts, even in developed countries. Just to introduce the discussion, I'm sure that you will have other questions. Do you think that there is, since you capture in a very nice way a barrier to adaptation to climate change, do you think that there are, which are somehow the remedies, how this can be solved from a policy point of view?
Yeah, well, yeah, I didn't include them here, but I would say that quite straightforward policy implications would stand on the side of more direct, more efficient communication in terms of timing of drought events, and therefore sharing, so that you know, in some sense, the idea here is that farmers do not have the same information set that climate scientists do have. In a sense that I started from as a starting point saying, okay, there is scientific consensus around the impact of climate change. Perhaps this is not the case for rural households. And given that these communities are those that may be more vulnerable, indeed, it is even more important to make sure that they enlarge their information set in terms of weather realizations and future climatic changes, so that they can better implement timely and efficient adaptation strategies.
Thank you. Other remarks or questions?
Anna, I'd have a question.
Yes. Hi.
Hi, Guglielmo. Thanks a lot for a very, very interesting presentation. It's, I mean, it really went fast, so I'm not sure I captured all of the methodological details, and it would deserve much more time. But what really struck me is the first evidence that you provided on the shift in the subjective perceptions between the two campaigns. Like from 1 year to the next, we go from 1 quarter to 3 quarters. So yeah. It's really massive. And I wonder whether you have any explanation for that, whether you have thought about it or found ways to investigate that, and in particular, whether there would be any possibility that there's an external factor triggering it. Like, for instance, you could think of a major campaign from the government to raise awareness on climate change, and even on possible confounding factors. Think of a technological shock, like the irrigation technology becomes all of a sudden more available. That has, as you said, affordability is an important element of the adaptation decision. And through a wishful thinking kind of effect, it could also modify people's perceptions of climate change. So is your estimation strategy immune to this kind of confounding factors?
Yeah, thanks a lot. No, this is a great remark. So as I said, what is even more interesting about these summary statistics that you were referring to between the two waves is that, in fact, there is no objective counterfactual of any, say, big drought event that has been recorded in the same time period. And this is, I mean, to some extent, if we're talking about erratic rainfall, it relies on the variability, so this may be more disputable. But when we're talking about increases in droughts, why should you be changing your beliefs between 2 years when there is no evidence for that? And when we are talking about a longer time horizon, right? Because these questions refer to the 20-year, to the previous 20 years. So for this reason, I really felt like, okay, I need to embody in all the analysis any kind of potential objective measurement to build as a counterfactual for this. And you're totally right on this. In terms of raising awareness of climatic changes between the two waves, this is something that I am not aware of, that I've investigated it, because indeed that would create a great, say, exogenous shock between the two waves that I could actually exploit. But unfortunately, this has not been the case. Another important fact is that, in fact, the way the questions have been formulated between the two waves is slightly different. So there may be some, say, survey bias that stems from the measurement. So here I'm really trying to be as, impartial, unbiased as possible in the measurement of them, but still, even just the order of the questions, the way they have been asked, or whether it was a multiple choice question or a binary question, and which is the case that the two different between the two waves may explain the different, surprising difference between the two waves. So you're right. In terms of your second point was in terms of technological shocks. So something that I haven't really highlighted during the presentation is that I'm focusing on the outcome is really the share of cultivable land that is irrigated. Therefore, the irrigation infrastructure is already there. And given that I have a household fixed effect, I'm exploiting the within individual variation between the two waves in such a way that it's not whether they have there was any kind of, say, potential other constraint that was limiting them from implementing that, but it's really like the allocation of their land holdings weighted by the size of the dimension and how much this drives their, it is driven by subjective perceptions, if that answers your questions.
Yeah, it does. I mean, it remains the, possibility of confounding factors that we can think of, but I find indeed this change really intriguing and yeah, worth maybe looking more into. Great, very interesting.
Thanks.
As a complement to this idea of shocks, during these 2 years, or referring to the years where the question was asked in the survey, do you register very extreme events?
So let me just, this is because yeah, the hyperlinks were not working initially. I have not, well, here I just have here I have the number of the moderate, severe, and extreme droughts that have occurred. This is at the total, like this is I've pulled both waves, so this means that perhaps the maximum will refer to the first wave because it has a larger time span, and you can see that there are some unions that have experienced 3 extreme drought events. So in terms of weather shocks, there have been some, and there is a lot of heterogeneity across the different unions. You see that still the average is quite low, but then if we increase, if we say relax the cutoff of the drought using like moderate droughts, then you see that everyone has experienced at least, each union has experienced at least 1 drought event. And this is why I was more prone to use extreme drought events as the objective measure, because this would definitely otherwise somehow downward bias my estimate of the accuracy, in a sense that you can see, and this is something that I tried to make clear earlier. Here you see that all the delta measure by looking at the moderate droughts and severe droughts would clearly be downward bias otherwise.
Yeah, my question was to be more precise, maybe can you think that it's possible that the zones that have experienced drought events have a memory effect or a perception, therefore, that is also affected, that is different? You know, maybe in the sense that if I live in a zone where assume that the 3 events have hit the same zone, maybe my perception will be different with respect to a zone where even if you had more frequent event but less drastic.
Mm-hmm. I see. Yeah, no, it's a very good point. So this somehow, if I'm not, correct me if I'm not wrong, relates to the different features of the mechanisms that I wanted to explore. So in a sense, we all know that, especially in terms of droughts, we have the severity of the droughts, so how much harmful the drought is, and then how many droughts have you experienced. And in fact, this is what I wanted to explore in the mechanisms when I talk about the timing of the most harmful drought. So here I'm looking at the severity, as you said. So provided that you take the maximum, say the most harmful drought, and I look at when it occurred, and then I look at whether the number of drought events, so for example, being exposed, as you said, to 3, but say perhaps without any inference on how hard these events were. Okay, so the last exercise that I did using the delta measures were really just, I asked, like not me, but I mean the survey asked to the farmer, how many events have you been, drought events have you been hit by in this given period of time? And then I computed the objective measure, okay? So this is just the number. Whereas another question, which is the one that I exploited in the first mechanism, was asking when were you hit by the most harmful drought? So this does not ask you how many you have experienced, but only when the most harmful was. Well, indeed, if you just report 1 drought event in a given time period, that will also correspond to the most harmful by construction. But if you have, say, more than 2, and in fact, we have seen that many people state up to 11 drought events to have experienced, then in that case, they will pick up the year in which the most harmful has occurred, and they will state that.
And do you have also the possibility of perhaps in other parts of the survey to have some data on the impact on productivity?
Impact on, sorry, what?
Do you have also the possibility of measuring the impact on productivity?
That's the biggest, yeah, no, that's the biggest flaw of this study, in a sense that you have seen that the outcome variable is the explicit measure of adaptation. But as looking at whether this has had an impact on the outcomes, say productivity, profits, or anything like that would be great. I agree with you. Unfortunately, just to give you, this is the way the survey has been designed, is that there is no it was not questions on production were not measured in the second wave. And also when I was describing just to give you an idea on the summary statistics on the on the plot utilization, and making the case for why it makes sense to focus just on Raman and Boro, you see that here it's just one wave, because yeah, the module is absent in survey wave 2. No, this is would be really great. I agree with you, because up to now, as I said, I always say, okay, this might be suboptimal, in a sense that if I perceive a drought, and if I have experienced a drought and I increase the land that is rain-fed, this may be suboptimal. But it would be great to test that.
Yeah, because it depends on some specificities of the production process, agricultural production process, that I do not know in details, but whether it is suboptimal or not to be, labeled as such, it means that you have to because of the misperception, you should have a loss somewhere. And for what you give evidence is just the dimension of perception, but not the consequences. So the story you can tell is, the consequences on adaptation remains open, in the sense that we don't know whether, thanks maybe to this excess response, maybe they had in mind something like a constant revenue or a constant yield. So I'm just questioning the wording, as in terms of adaptation, is that perhaps it cannot be measured as long as we don't have the impact.
I agree. No, you're totally right. That's why I always try to be as cautious as possible in the presentation, by saying, let's say in our mindset, potentially this would be classified as a suboptimal decision, right? If we see that you overreact, or you leave more land that is rainfall. But I totally agree with you that further mechanisms and potential production decisions would then need to be tested on final outcomes, say the production, the profits, the yields, and so on. Totally agree with you. But unfortunately, this is a limitation of the data.
No, I understand. When studying this phenomena in developing countries, this is the most important limit. But exactly, this just represents a way for us to find the right terms in presenting our research.
Yes, thanks.
Other questions or remarks? Okay, so thank you very much for sharing with us your research, and Catherine as well. And see you soon for the next seminars.